All right, welcome to Planck's number 2. Okay. Earlier in the last video, we talked about how to calculate the speed of light, which is the frequency, or the wavelength times the frequency. We learned how to manipulate it and what the units were. We know that the speed of light is 3.00 times 10 to the 8. Now we're going to take it a step further. We are going to talk about energy of a wave. In the past, I've told you, or in class we talked about how wavelength and frequency are inverse of each other, so that as one goes up, the other goes down. When we talk about energy and frequency, as one goes up, the other still goes up. So if frequency increases, energy increases. Okay, so we have a formula for that, and that's E equals hv. E stands for energy, and it's in joules. H is a Planck's constant. You don't have to memorize this. I'm going to give this to you. But it is 6.63 times 10 to the negative 34 joules per second. And that is a negative up there. The V stands for frequency in hertz or seconds. So either one, like we said before. So let's go ahead and start working some problems. I gave you the problems in class. You got 3 to do with that we're going to do together, and 4 that we're going to do together. No, 3 we're going to do together. Sorry, I have to take it back. 3 we're going to do together, and 3 you're going to do on your own. So I can't read my own writing. So first thing we're going to do is read number 1. What is the energy of a 3.66 times 10 to the 14th hertz wave? So you're going to circle the 3.66 times 10 to the 14th hertz. You're going to underline the word what is the energy. You're going to put an E above that with a question mark, and you're going to put a V over the hertz. Then you're going to start plugging it in. E equals 3.66 times 10 to the 14th times, we're going to plug in Planck's constant, 6.63 times 10 to the negative 34. When you plug this in your calculator, you are going to get how many significant figures? Let me back it up. We need to know how many significant figures. So I've got 3 here and 3 here, so I need 3 significant figures. So I'm going to round this to 2.43 times 10 to the negative 19, and I'm going to put joules. Why? Because the units are going to cancel out, and we know that energy is in joules. Okay? So far, not so bad, right? We're just going to multiply because that's what we're doing to find energy. Okay? So let's do another one. Number 2. Remember, fast forward if you don't want to see me erase. I don't have any way to cut it out, sorry. Number 2, what is the frequency of a wave with 8.2 times 10 to the negative 18 joules of energy? Circle the 8.2 times 10 to the negative 18. Put an E over that. And then you're going to put a V over the frequency, and you're going to underline what is the frequency. Okay? So, E equals HV. Okay? I have my E and I have my H. So how do I rearrange this formula? Well, if you think about it, you're going to isolate the E, so you're going to have E over E over H. Let me erase that a little bit better. Sorry. Let me rewrite this whole thing. Sorry. E over H gives you your V. Okay, so we're going to plug in our numbers. Well, we circled the 8.2 times 10 to the negative 18. We're going to plug it over our constant, which is 6.63 times 10 to the negative 34. You plug this in your calculator, and we need 2 significant figures because it's the lowest. I've got 2 here and 3 here, so I want the lowest one. So I'm going to round this to 1.2 times 10 to the 16th, and then I'll put hertz because it is a frequency. Okay? So far, not so bad, right? The only thing is you got to remember to rearrange your formula or do algebra. Isolate your x. Okay? So let's go ahead and do another one. Number 3. This is where it gets a little bit tricky. Okay, so if you read the problem, and I'll let you read it real quick and look at it and see what you think. See if you can underline and circle what you need. What is missing? Okay, so think about what is missing. What do we have? What do we don't have? Okay. All right, so it says, what is the wavelength of a 7.65 times 10 to the negative 17 joule wave? Well, if I look at my formula for energy, because I have joules, I don't have a wavelength, right? I don't have a wavelength in this problem. So what am I going to do? Well, I only have a wavelength in my speed of light, but I do have a frequency. So if I find frequency with my energy, then I could plug that frequency into my speed of a light equation, and then I get my answer. So in this equation, we're going to take, or in this one, we're going to circle 7.65 times 10 to the negative 17 joules and label it E. We're going to underline the what is wavelength and put a lambda, a little upside down Y. So first thing we're going to look at is energy equals HV. But I know I have to take this and I have to find my frequency. Okay? So I have to take energy over my Planck's constant to get me my frequency. I still need wavelength, but my formula up here is C equals wavelength times frequency. So C equals wavelength times frequency. I can rearrange this. Now I have this V. So I take C over V, gives me my wavelength. So I have to use 2 of these. This is where it's going to get tricky. You have to be careful. Don't stop here. Make sure you plug it in if you need wavelength and you only have energy. Okay? So we're going to plug this in. Let's plug our numbers in. The first number we have is 7.65 times 10 to the negative 17. Okay, negative 17. And we are going to plug that in over our 6.63 times 10 to the negative 34. Plug it into our calculator and we end up with 1.15 times 10 to the 17. This is our hertz. So that is equals our V, right? But that's not what our question asks for. It asks for wavelength. So let's take this, let's plug it into here. We rearrange the formula, so we're going to use this one down here. So we're going to take 3.00 times 10 to the 8 meters per second. Okay? We're going to plug in our value, 1.15 times 10 to the 17th. Okay? And we're going to get 3 significant figures. So, and I put 3 significant figures here, so I just kept it all together. I'm going to do 2.61 times 10 to the negative 9. Now, one thing I did forget to do and forget to tell you is you're really not supposed to round until the very end. Okay? I rounded for right now, and I didn't mean to. I just realized I did that, but this will be your final answer. Okay? So, don't round until you get to the very end. I made that mistake. If you guys come up with a different number than 2.61, let me know when we get into class. What if I wanted to turn this to nanometers? How would I do that? Plug in a railroad track. You're going from meters, which is 2.61 times 10 to the negative 9. Meters goes down here, and nanometers goes up here. And if you remember 1, and this is 1 times 10 to the negative 9. And you can kind of figure out what it is from there. Okay, so come to class, bring your note, bring this and your 3 work at home. See if you can get those 3 at home, and we'll discuss them in class and see what you guys came up with. Okay, see you in class.